Good morning. The weather is lightening up. 5 o'clock this morning when I took the train, it was pretty miserable. Wimbledon's here. So those of you who are regretting coming to BAUS, I suspect you'll be hooked onto your TV. So everything's looking bright and sunny again. It wasn't looking particularly bright on Friday when I received a phone call from the winner of the John Blandy Prize saying that a member of his family had fallen ill. I know he was due to come because we had booked him a room in the Jury's Inn. But we'll make up for that in a minute because it gives me the opportunity to speak to you about a few innovations the BJUI has done in addition to the John Blandy Prize. First, the prize. The John Blandy Prize is historic. It is one of 3 prizes that the BJUI gives. It is the prize for the best paper within the UK and Europe within the last year. The other 2 prizes are the Global Prize for the rest of the world and the Crane Coffee Prize for the Americas. So this is a very prestigious honor for the recipient. But what has the BJUI in the meantime been up to while we have been deciding with a panel as to who to give the John Blandy Prize to? The first is the introduction of infographics. If you go on to www.bjui.org, we have made papers even simpler for you. When I started 4 years ago, I thought your attention span is about a minute and a half. I now realize, looking at data from the BBC and other sources, that actually our attention span is less than a minute. I can see Howard's eyesight already wavering. He's looking at the water outside. He's looking at the ladies at the back, etc. So already I realize that this hypothesis is absolutely correct. So we have brought in infographics, and apart from JAMA, we are the first such surgical journal to do so. So this is an example from nephron-sparing surgery in the United Kingdom, and the highlights are quite simple and stark. The worrying thing is that over 30% of patients with small tumors are benign. This is rather shocking, and perhaps we need to have that debate yet again as to whether we should be biopsying these tumors before we attack the patients with a knife or a robot or a laparoscope. So this is an important highlight from the paper. The other highlight, of course, is that many of our colleagues are doing 4 or less of these a year. Again, slightly worrying, I think, for such a highly complex procedure, and I leave it to you to debate as to whether us being a small island, that is good enough. We just accept we are a small island. That's it. Otherwise, we would have to move patients even more centrally to larger centers. So this is entirely up to you to debate, but the premise of this is to put the data out there from large studies like the BAUS database and condense it into a single infographic that you can read and understand in less than a minute. The next thing that has happened, and you will hear more about this tomorrow, is the PROMISE study. The PROMISE study was just presented by Hashim Ahmed 2 weeks ago in ASCO as an abstract, and this is the first article on PROMISE, and it appears as an editorial in the BJUI July issue. I got Hashim to write this, and I have called it the promise of MRI, but I won't steal his thunder and that of Mark Emberton, because this is going to be presented along with PROTECT tomorrow morning. So I would encourage you people to attend and listen to the authors of these large randomized, possibly landmark studies. Now, for those of you who are not going back and are still here on Wednesday afternoon, I encourage you to come to the BJUI peer review workshop. This is in collaboration with the Journal of Urology and European Urology. You have all 3 editors in the same room, which hasn't happened many times before, I can tell you, to teach you about how it is to do a proper peer review. There are 30 places on this workshop, so time is tight, time is short, but this is a unique opportunity for you to learn from all three of us in the same room, telling you what to do when you receive that paper through your email and how to deal with it. And finally, the Blandy Prize. This year, the Blandy Prize goes to Erik Rudd. Erik is a trainee from the Oslo University in Norway. And the paper is fascinating because it looks within a randomized trial as to how good MRI is at detecting the index tumor and then comparing it to the tumor volume and tumors in other locations in excised radical prostatectomy specimens. And what it says essentially is this. For detecting the index tumor, MRI is 92% accurate. However, for tumor volume and for tumor at other sites, it is not as good. So I think MRI is getting better. It is not quite there yet, and you could argue that locating the index tumor, while may be very useful to the patient, may not always be all that is necessary given that prostate cancer is multifocal, and often you can get aggressive tumor at other sites with increasing volume compared to the index tumor. So again, this is open to debate. It's a very exciting area, and I think in future with metabolic MRI coming to the fore, MRI itself getting better, we will get as close to 100% as possible, but in 2016, we are not there yet. So I invite John Davis, who is an MRI expert and knows Erik Rudd well. John, you actually could pretend you're Erik for a short period of time to come up and receive the John Blandy Prize. A round of applause. Thank you. Can we now play the video from Erik Rudd, please, all the way from Oslo? Thank you.
Hello to you all and greetings from Oslo, Norway. My name is Erik Rudd and I'm the radiologist and the first author of this paper titled Detection of the Index Tumor and Tumor Volume in Prostate Cancer using T2 and diffusion weighted MRI alone. I would like to thank the BJUI panel for awarding our paper the 2016 John Blandy Prize. I hope you can accept my apologies that I had to cancel my travel plans and I can't be with you to accept the prize in person. However, I did this recording in order to give you an overview about the work behind the paper and some words about the key results and conclusion. I thank all my co-authors for contributing to this paper. Now, what is so special about this paper? We have all seen a lot of MRI detection results, and what is so special about this one? I think there are a few things that makes this paper different from all others. First of all, we focus on the index tumor, and second, we try to assess how well MRI can estimate the tumor volume, and third, we use a very simple MRI protocol, much simpler than most other centers. I think we all can agree on that MRI is increasingly being used prior to prostatectomy, and we use it for cancer detection and volume estimation, and also cancer T classification, which is probably the main interest of you as urologist. But we don't know too much about how it affects the surgical procedure, and we don't know how MRI affects the surgical outcome. Are we sure we actually improve treatment? I don't think we can say that. So the main research question in my PhD study was to answer whether preoperative MRI improved the surgical results. And this is why we chose randomized study design where half the patient received MRI prior to prostatectomy while the other half did not. In that way, we could compare the surgical results in the two groups, and we can also compare the surgical techniques in the two groups. And this is the main focus of paper 3. In paper 2, we present the staging results, and in paper 1, which is the topic of today's speech, we present the MRI results in respect to detection and tumor volume estimation. Just a brief overview about what I mean about the index tumor. So in, let's say, around 80% have multifocal cancer, but all of these cancer folds are not equally important. So the index tumor is defined as the clinically dominant cancer focus. And it's usually defined as the tumor having extraprostatic disease, if any is present, or the tumor with the highest Gleason score, or the largest tumor volume. So in that order of priority. I told you that our MRI method is very simple and simpler than most other protocols, because we don't use contrast enhanced images, we don't use spectroscopy. And how is still possible to visualize cancer? That's the question. And the answer is diffusion weighted imaging. This is a functional sequence that has the ability to measure and quantify the restriction of water molecules. So you can imagine in every tissue you have a certain movement of water molecules, and as the cellular density increase, as it does in cancer, you will have less space to move about for water molecules, and this restriction in diffusion can be measured and quantified. And you can see on the image, MRI image on the right side of the screen, you have the anatomical T2 weighted image, and you have some color overlay image where the bright color and red color indicates restricted diffusion, and it's highly suggestive of cancer. And you can see on the hole-mounted histology slide that it corresponds very well to the highly dense tumor seen on the right lobe, while we cannot really see the tumor, which is less dense, on the left lobe. So we included 200 patients in the MRI arm, and we did this T2 and diffusion weighted acquisition, and we registered the location and the volume of the index tumor, the secondary and tertiary tumor, and compared these results to the pathological reference standard, as the pathologist did the exact same registration. And in this way we could compare the results and decide whether the index tumor was detected or not. We could also compare the tumor volumes based on the two methods using the ellipsoid tumor volume form. And as you see, there's a quite high detection rate for the index tumor, reaching more than 90%, while the detection of the secondary and tertiary tumor is around 40%. So the reason for that is usually because of much lower volume of the secondary and tertiary tumor. As you see in the image, this is quite a typical situation. We see the large index tumors, but we have no way of identifying the smaller tumors. And I think that's quite a general problem on a MRI platform today. And remember, we talked about 3 defining criteria for the definition of the index tumor. So it was extraprostatic disease, highest Gleason score, or the tumor volume. But in this study showed that we found the highest ranking criteria in the largest tumor in 97.5%. So that means if you look for the largest tumor, you will find the tumor having extraprostatic extension. You also find the tumor having the highest Gleason score in the absolute greatest majority. And only 3 patients, the highest Gleason score was found in the second largest tumor, and only 1 patient, the second largest tumor had extraprostatic extension, while the largest was localized. So look for the biggest tumor also during biopsy and also during surgery, and you will probably find the most interesting or clinically significant cancer. Here it gets a little bit more complicated, and I always find it a little bit difficult to explain this, so I will give it a try. In this slide, we try to report how well MRI can assess tumor volume when compared to the histological tumor volume, which is the reference standard or reference volume. And you see in A, it's a simple scatter plot diagram showing there's a quite good correlation between the MRI measured tumor volume and the histological tumor volume. So it has a Pearson coefficient of 0.8, and this gives an impression that, well, MRI is actually quite good at assessing the tumor volume. But from a clinical point of view, that's really not the case, and for that reason I think that the blunt Altman plot is much more suitable for this purpose. This is also called the difference plot, and we plot the difference between the MRI measured volume and the histological volume versus the average tumor volume based on the two methods. And you see that in the optimal situation, all the dots should be on the zero line, because that means there is no difference between the two volume measurements. And the range of error defined by ±2 standard deviation, this range of error should be as small as possible, and at least it should be clinically acceptable in order to say that, well, MRI actually measures the same volume as the histological volume. And you see all the red dots. You have a lot of them above the zero line, and that means overestimation of tumor volume. And you see even more dots below the zero line, meaning underestimation of the tumor volume. And you see it's a quite substantial range of disagreement between the stated lines. So in conclusion, we can say that, well, there is a correlation indeed, it's highly significant, but it's a great variance between MRI and histology when comparing tumor volume. So you cannot really say that MRI accurately measures the tumor volume. It's a too large discrepancy between the two methods. And the reason for that is, as you see in the MRI image, we have no problems identifying the highly dense tumor on the right lobe. But we cannot see this less dense tail which extends into the left prostate lobe, and therefore we will underestimate this tumor volume to a quite great extent. And this is a quite common situation. And we have the opposite, where we overestimate tumor volume. That typically appears in, or typically happens in the transition zone, where it's quite difficult to see where the tumor starts and where it ends, and distinguish tumor from adenosis and so on. So both over and underestimation occurs. And that brings us to the conclusion, and I think we can say that MRI detected the vast majority of the index tumor, even if we used a very simple examination. And remember that we only use 1.5 Tesla MRI, and we did not use endorectal coil, and we did not use contrast, we did not use spectroscopy, and still we have results comparable to studies that have used all imaginary equipment. So in a way, I think it illustrates that it is possible to have good results even when doing it simple. And this has an impact on the availability of MRI examinations. I mean, if you can do it simple and fast, you can offer this examination to more patients, and that should be a good thing. It is also important to highlight the limitation of MRI for assessing tumor volume, and I think the clinicians should be quite careful when using MRI measured tumor volume for deciding treatment. You shouldn't use it like literally. So if you measure tumor volume of 1 cc, you should be aware that it might be much bigger and it might be much smaller. So, once again, I would like to thank the committee for awarding us this prize, and I hope the audience have enjoyed this presentation, and I hope you will continue to have a good day and enjoy the rest of the week in Liverpool.
Let's switch that off,
Thank you so
please.
much.
Thank you very much, Eric. Almost as though it didn't matter that he wasn't here. So that was very niftily done.